Module 2, Lesson 9, the summarizing of bivariate categorical data. So there are two outcomes: distinguish between categorical data and numerical data, and then 2, construct a relative frequency table and interpret relative frequencies. So in this lesson, the class started with this scenario that you're going to see occur through most of the upcoming lessons. They talked about superheroes, which have been popular in the movies as of late. We've all seen the Marvel and Spider-Man and all these coming out lately. Some of the ones that they know was Captain America, She-Ra, and Fantastic Four. And so the article goes on to say what is special about a certain superhero, and are there any special superhero powers that are particularly popular amongst students. So a survey was done where it said high school students in the United States were invited to complete an online survey in 2010. Part of the survey included questions about superhero powers. So more than 1,000 students responded to this survey that included a question about a student's most favorite superhero power. 400 of the 50 surveys were randomly selected, and a rather confusing breakdown of the data by gender was compiled from these 450 pieces of data. And so we have it right here where it said 100 students indicated to fly, 49 of those students were females, and it continues to go on. So the teacher just starts off as anticipatory set what might be their favorite superhero of the class and what might be their favorite superhero power that they would like to have. Now, talking more specifically, the data itself, and this is where example 1 comes into play, and we look at it more particularly and just get the students to think about what they're seeing. So we know already that this data is a sum of 450 different surveys, and we know that some of these are broken up by totals and then over here broken down by females. So if we just look at the questions, it says what is the most popular superhero power? And so by looking at it, we have 100, 131, 75, 26, or 118. So the students might say their most popular superhero power is freeze time. And so then the teacher kind of asks what was maybe the least superhero power that you could see. And then super strength would be the one the students would note would be the least popular superhero power, being that only 26 students out of 450 chose. Would the survey include gender? Because this would give the opportunity to investigate whether there is a difference between a selection of superhero power between male versus females, because it could conclude that females like one superhero better, and then males may like another superhero power as their preference. And then the superhero question comes up: do you think gender plays a role in superhero power as a preference to the students? Answers will vary. There's not a right or wrong answer here, but this is just to get the students thinking about this particular data and what they feel some of the results may start to describe or include. So in exercises 1 through 4, it talks about how many more females than males indicated their favorite power is telepathy. So if we go in and look at telepathy, this is down here at the bottom. It says 118 students indicate telepathy. 70 of those students were female. So here's what we know. We know that 70 were females that liked telepathy. There was 118 surveyed total that liked that. So if we do 118 minus 70, then we know that there are 48 males that also voted for telepathy as their favorite superhero power. So the question was how many more females than males? So we'll take and we'll subtract these two values, the 70 minus the 48, and we'll know that there were 22 more females that preferred telepathy than compared to the selection of males. In number 2, how many more males than females indicated their favorite superhero power was to fly? So we look at the superhero power to fly, which is right here. 100 students indicate their favorite power is to fly. 49 of those students were females um, in that particular piece to fly. So how many more males than females indicated their favorite superhero power was to fly? Um, 49 were females. And that means if we did 100 minus 49, that would be 51 males that voted that as their favorite superhero power. And so if we subtract that, that would mean 2 more males than females selected flying as their favorite superpower. Number 3 states, and this is an open-ended question for the most part, write survey questions that you think might have been used to collect this data. One of the questions would be on the survey could be potentially, what is your gender? And that's derived from the fact that our category is derived into males and females. And another question could be, what is your favorite superhero power? And the choices were to fly, freeze time, invisibility, super strength, or telepathy. And then 4, how do you think the 450 surveys using example 1 might have been selected? You can assume that there were 1,000 surveys to select from, and it was just by random selection, and students could come up with any idea of how they believe they were randomly selected. Could have been out of a drawing from a barrel. They could have all been face down in a room, and 450 of them was collected. It could have been the first 450 that were turned in. Just different things that the students might think could represent that random selection out of the 1,000. So in example number 2, we introduce and start to just define this idea of a bivariate categorical data. And what it means to be bivariate categorical data, well, bi refers to 2. So what are we looking at here is 2 styles of data. Here we're talking about gender, so male or female, versus across the top here is the superpower. And so we're trying to compare 2 different types of data in terms of our information. So the first step to analyzing this type of data that was collected, this bivariate data, is to create what is known as a two-way frequency table. And so that's what we see down here, a two-way frequency table where we can look at it and say in a moment how many females like to fly, or how many males chose invisibility as their power. And so we kind of use a grid method, so where we'd slide this over males versus invisibility, and that would link to that data, versus over here females that like to fly, in that perspective right there. A two-way frequency table that can be used to organize this data is shown below, and so forth. So looking a little bit deeper in this design, the shaded regions of the table are called marginal frequencies. So this area right here, this shaded region all along the bottom, and then these 2 pieces right here are the marginal frequencies. The marginal frequencies. They are located around the margins of the table and represent the totals of the rows, of the columns in the tables. And what they mean by that is if I was to add up each of these pieces across here, it would sum up to equal R, same as if I was to add up F plus I, it would equal R. It allows the students a good check to make sure things are working out properly while they're working this. The non-shaded cells within the table are called the joint frequencies. So everything else is considered the joint frequencies. That would be these pieces all along here. Each joint cell is the frequency count of the responses of the 2 categorical variables by the intersection of row versus column. So at this point, the teacher would give the students an opportunity, 10 minutes, to work and discuss and talk about looking at that data, that categories, and seeing can they figure out which one goes where. So after that 10 minutes passes, the students come to the conclusion at looking at, well, 49 females chose to fly, 60 females chose freeze time, and so forth. So what are we looking at that's interesting is here we've got 228. This number is determined by summing this first row, 49 plus the 60 plus the 48 plus the 1 plus the 70 will equal 228. And same thing here, if we added up this particular row, that would equal 222. These were our marginal frequencies here. This marginal frequency was attained by adding 49 plus 51 equals 100, 60 plus 71 will equal 131, and this same general pattern continuing to demonstrate itself down each particular table. And then finally our marginals we mentioned from the last slide. Everything in this row will sum to equal 450, and likewise 228 plus 222 will also equal 450. And so this is our two-way frequency table to represent our bivariate categorical data. The next lesson is going to pick up where this one leaves off to talk a little bit more about what I can do with this particular table. But in a lesson summary, categorical data are data that take on values that are categories rather than numbers. Examples include male or female or categorical variable of gender, or the 5 superhero powers that we discussed. A two-way frequency table is used to summarize this bivariate categorical data. And then the number in a two-way frequency table at the intersection of a row or a column of the response of two categorical variables represents the joint frequencies. The number total of responses for each value of categorical data in the table represents the marginal frequency of that particular value.